All right, skill 14, solving a system of linear equations with substitution. So we have two problems. Each problem has two equations, and your job is to figure out what's the value of x and y that is a solution to both equations. So if you were to graph these and they had a single solution, it'd be like graphing two lines, and you want to figure out where these two lines cross. And when two lines cross, they have two coordinates, x and y. And I mention that only because when you're trying to find the solution to these systems of equations, you're looking for two answers. So both variables have a value. So for letter A and B, you've got to find values for x and y. And we're going to substitute. So substitute means you can take one entire half of the equation for one variable equals and put it in the other. Both equations are already set up for substitution. This equation says that anytime you see a y in this problem, you can substitute it. It's equal to a 2x plus 5. This one says that y is substituted with a 3x minus 6. I'm going to take the second equation and take what y equals here, the 3x minus 6, and I'm going to substitute what y equals into the first equation and replace this y with 3x minus 6. So I can rewrite this first equation. Instead of saying that y equals 2x plus 5, I can say that 3x minus 6 equals 2x plus 5. So I'm substituting what y equals in the second equation into the first equation because now I have one equation with only one variable type, x, and I can solve this for x, go back and use either equation, solve for y, and that's going to be my solution on my value of x and my value of y. So first, to solve this, I'm going to subtract 2x to both sides, and I get 3x minus 2x is x, x minus 6 equals 5. If I add 6 to both sides, I get x equals 11. So that is one of my solutions, but I have to find the other variable, in this case is y. And I can choose either equation to find the y value. It doesn't matter, it's going to be the same value. I'm going to pick the first equation because it comes first. So I have y equals 2x plus 5. If I substitute an 11 for the x, I have 2 times 11 plus 5, which is 22 plus 5, which is 27. So those are my two parts of the solution, what x equals and what y equals. If I would have chosen the second equation to find y, 11 times 3 would be 33 minus 6. It's also 27. So your solution can be written as x equals 11, y equals 27, or sometimes you write it as an ordered pair in alphabetical order, x and then y. And you can put it like this in parentheses because it is like a point where those two would cross and intersect. Second problem, the first one says y equals negative 3x plus 7. The second is 3x plus y, or 4x plus y equals negative 5. The second one doesn't say what x equals by itself or what y equals by itself, but the first one does say what y equals. So this is my substitutor I'm going to use. The first equation says, hey, every y in this problem can be substituted with negative 3x plus 7. So I'm going to take out this y and substitute with negative 3x plus 7. So I recopy that second equation, but instead of writing down 4x plus y, I'm going to write 4x plus negative 3x plus 7 equals negative 5. So I substitute what y equals from the first equation into the second equation. Now I have just x to simplify. 4x and 3x minus 3x is x. I have x plus 7 equals negative 5. To solve for x, subtract 7 to both sides. I get x equals negative 12. But once again, that's only half of my solution. I need the y value. So I can pick either equation to solve for y. But I would rather pick one that's simpler. The first one says that y equals this math done with the variable x. I know x is negative 12. I'm going to choose the first one. It's more straightforward than the second one. So I know that y equals negative 3x plus 7. But I can substitute what x equals, which is that negative 12, and I can solve this for y. So negative 3 times negative 12 is 36. 36 plus 7 is 43. And that is my value for y. So my solution, once again, could be written as an ordered pair. X is negative 12, y is 43. And that is the solution to that system of equations using substitution. All right, here are two problems for you to try. Same direction, same kind of questions. Solve each system using substitution. Pause the video, work them out, watch the rest of the video, see how you did. All right, you should have these two problems done. First one, I'm checking first to see what can I use to substitute. This equation says that x plus 2y equals 6. It doesn't tell me what x equals or y equals. The second one says x equals negative 3 minus y. I'm going to choose this for my substitution amount because x is by itself on one side of the equal sign. And I'm going to substitute this value of x with what the second equation did. So I'm going to kind of substitute the two equations together inside one another. So I'm going to rewrite the first equation. Instead of x plus 2y equals 6, I'm going to put in what x equals, which is negative 3 minus y, plus 2y equals 6. So I substitute what x equals from the second equation into the first, and I create this equation, which only has one variable, type y. Negative y plus 2y are like terms, so I can write that as negative 3 plus y equals 6. If I add 3 to both sides, I get y equals 9. So there's my value of y. But like before, we're finding both variables, so that's why I've got to find x. So my job is to pick either equation and solve it for x if I know y is 9. I choose the second equation because it tells me that x equals negative 3 minus y. So if I put into that equation a 9 in place of the y, that means x equals negative 3 minus 9, which is negative 12. And that's my solution to that system. It's like a point if we were to graph them where they cross. And my point has this x-coordinate, negative 12, and this y-coordinate, 9. So that's my solution. Second one, they both say y equals, so I can substitute one into the other. They both tell me what y equals. I'm going to take the first one this time, and this says y equals 5x plus minus 1, and I'm going to take that value for y, the 5x minus 1, and say, hey, the second equation is going to get that replaced with it. So I'll recopy the second equation, and instead of writing y equals 11 plus 3x, I'm going to write 5x minus 1 equals 11 plus 3x. And I get x's on one side of the equation and solve it as you probably have seen before. I'm going to minus 3x to both sides. I get 2x minus 1 equals 11. I'm going to add 1 to both sides to get x by itself. I get 2x equals 12 if I divide both sides by 2. X equals 6. That's only one of my solutions. There's two variables. I need two values, one for each variable. So that's x. I've got to find y. And both equations tell me what y equals. I got to pick one of them and solve for x, or solve for y. I know x is 6. I'm going to pick, I don't know, second one. Y equals 11 plus 3x. If x is 6, that means that y equals 11 plus 3 times 6. 3 times 6 is 18, and 11 plus 18 is 29. So that is my y value. So that's my solution. X is 6, y is 29. Or if you write it as an ordered pair in parentheses, alphabetical order is the standard, so